Hi everyone, welcome back to my channel. Today's video is about chi-square goodness of fit test. It is a single sample non-parametric test, or Pearson's chi-square goodness of fit test. When an analyst attempts to fit a statistical model to observe data, he or she may wonder how well the model actually reflects the data, or how close are the observed values to those which would be expected under the fitted model. The statistical test that addresses this issue is the chi-square goodness of fit test. And also, the one primary question leading to use this test is that, do all cases occur in equal proportion, or are they in the proportion of an expected distribution? For example, imagine that a new casino game involves rolling 3 dice, and the winnings are directly proportional to the total number of sixes rolled. And suppose a gambler plays the game 100 times with the following counts, as you can see. With 48 times out of 100 times, zero number of 6 appeared, and 31 times out of 100 times, one number of 6s appeared, and so on. So the casino becomes suspicious of the gambler and wishes to determine whether the dice are fair or not. So if a dice is fair, we would expect the probability of rolling a 6 on any given toss to be 1/6, and we assume that 3 dice are independent. To determine whether the gambler's dice are fair, we may compare his results with the results expected. This is an important aspect because hypothesizing whether you expect the proportion of cases in each group of your categorical variable to be equal or unequal will change the whole process. Not only is it an important aspect of your research design, but from a practical perspective, it will determine how you carry out the chi-square goodness of fit test in SPSS, as well as how you interpret and write up your results. In this example, we assume the probability of rolling a 6 on given toss to be equal. But before doing the test, we need to check for assumptions and make sure that they are not violated. Assumption number 1 says that one categorical variable can be nominal or ordinal, which here our data is ordinal since we can have 0, 1, 2, or 3 sixes in each toss of 3 dice. So this assumption is checked. And assumption number 2 says that you should have independence of observations, which means that there is no relationship between any of the cases. So dices here are independent and there is no relationship between tossing each of them. And assumption number 3 says that the groups must be mutually exclusive, meaning that a case could only be in one of the groups. And this is an obvious assumption here for our example. And assumption number 4 is that there must be at least 5 expected frequencies in each group of the categorical variable. This assumption is also met. So now we're good to go and do the test. Notice that when we enter group data in SPSS, I mean when frequencies or counts for each possible category are recorded, we must inform SPSS that counts are used instead of raw and group data. So to do that, go to data, weight cases, and in the pop-up window that appears, select roles as a variable that you're going to weight cases by. And now click on OK. Notice that if you want to do other analysis after goodness of fit test, you need to remove these weighting cases by clicking do not weight cases box in the same path that we have been to. So anyway, now to do the actual test, go to Analyze, Non-Parametric Tests, Legacy Dialogs, and chi-square. And now move variable success into test variable list box. And note that at the right corner below, for expected values, the all categories equal should be checked. This is where if the expected probabilities were not the same, we would define them and their values. So anyway, now click OK to run the analysis. So first table labeled as sixes, you can see that expected number for each of them is 25 out of 100 times rolling, or 1/4. And we see the actual observed numbers corresponding to each of them in observed number column, and also the residual column that shows the differences between actual number of rolls and expected number of rolls. So next table is test statistic, and it provides us with 3 results: chi-square statistic, degrees of freedom, and p-value. P-value here, as you can see, is 0.0, which is less than the alpha value 0.05. So we reject the null hypothesis, concluding that the dice do not produce equal distribution of rolls appearing 6, and so they're not fair, or the gambler does not use fair dice. And that was it. Thank you so much for watching this video, and I hope you liked it. And if you did, please like it and subscribe to my channel for upcoming videos.